Hey, welcome back to Business 101, Introduction to Business. And now in this fifth video in this series, we continue our look at information technology with the topic, as you see here on this slide, of information systems. So as we've talked about the basic building blocks of information technology and some of the ways that it has impacted business in contemporary life, we now look specifically at the systems, the types of systems that typically business uses to take all of this technology and put it to use for us. So you can see here, an information system is defined by the textbook as a system that uses information technology resources to convert data into information and to collect, process, and transmit that information for use in decision making. The distinction that is important to keep in mind here is that data and information are two different things. As the slide points out here, raw facts and figures that by themselves may not have much meaning are what we describe as data, whereas information is meaningful, useful interpretation of that data. And so, for instance, an example of this would simply be, 47. That's a piece of data. However, without a context, 47, perhaps that's the number of thousands of units sold last month by a company. Without a context, we don't know how to interpret that raw fact, that data. It's only if we know that, well, the average sales for the 12 previous months were 20,000, and this month we sold 47,000. It's then with that context that we're able to interpret and take that data and make it something more meaningful to us, if that makes sense. And you can see here back on the slide, the last point that I've added, never forget, data isn't really useful to business until it is converted to information. It is that conversion of raw data, basic facts and figures, into meaningful, useful information that is the real key and the real power and the promise of information systems. And so you can see here in this next slide that information systems managers, the managers who are responsible for maintaining and growing and keeping these systems working, the systems used for gathering, organizing, and distributing information, these managers have at least a couple of tasks in front of them. One of them is data warehousing. You see there in the second bullet point, which refers to the collection, storage, and timely retrieval of data in electronic files. So that's one part of the puzzle. The information system has to have meaningful data to work with, and the collection, storage, and retrieval of that data is called data warehousing. Data warehousing then is not to be confused with the third bullet point, data mining, which is in the later application of electronic technologies for searching, sifting, reorganizing that data to uncover useful information. It's one thing to collect all the data, it's another to mine it for useful analysis, interpretation, and to convert it into useful information. That's how we distinguish these two terms, data warehousing from data mining. Something to keep in mind perhaps for an upcoming exam. Then you see in this slide what we're really moving to is once we have data warehousing and mining taking place, then a knowledge information system can be defined by the text as a system that supports knowledge workers by providing resources to create, store, use, and transmit new knowledge for useful applications. Now that's a pretty general term. What does that really refer to? Well, let's give you an example or two. An example of a useful information system for knowledge workers, you see there in the slide behind it, this image, which is an actual image of computer-aided design, or CAD. CAD is defined as an information system with software that helps knowledge workers design products by simulating them and displaying them in three-dimensional graphics. And you can see here a three-dimensional rendered graphic by a CAD program designing what appears to be a internal combustion engine, an automobile engine that is designed solely in the software so that further work can be done to refine, polish, alter, adjust, and do all of this work in the computer, in the box, before actual steel is molded into a prototype of the machine. And so all the design is taking place within the box. That is related then to computer-aided manufacturing, or CAM, as you see here, the second bullet point on the slide, information systems that use computers to design and control equipment in a manufacturing process. So you can sort of see how these two information systems can sort of be hand in hand for knowledge workers. First with the design, and then later with the actual manufacturing. All of these information systems wielded by knowledge workers for useful production. We distinguish information systems for knowledge workers from information systems for managers. And you can see here the description from the text: a management information system, a computer system that supports managers by providing information, reports, schedules, plans, and budgets that can be used for making decisions. That brings up then the next topic: decision support systems, or DSS, an interactive system that creates virtual business models for a particular kind of decision and tests them with different data to see how they respond. What you see there illustrated is an actual screenshot from the U.S. Geological Service, a decision support system for the John Day Reservoir. And you can see here that the entire runoff system is displayed, and then decision criteria is served up to decision-making managers for them to be able to model and determine different sets of scenario consequences, and then make wise and intelligent and informed decisions based upon support from this very decision support system. Here is a graphical illustration. This is not in the textbook. I grabbed this from elsewhere on the web. A graphical representation of what we are trying to do to augment and improve real-world decision-making made by decision makers. And remember, we talked about that when we talked about one of the roles that leadership has is in wise, rational decision-making. Well, one of the ways we support rational decision-making is at the bottom of the pyramid, using data, this discrete objective facts about events, context, history, right? Answering questions like who, what, where, how many, when, why, and we convert that into useful information, which is described here by this graphic as data with analyzed relationships and connections, right? That's what converts the data into useful information. And then after that is contextualized to answer the question how, compared, action-informed, consequences, conversations, right? And then we use that information cumulatively as knowledge, contextualized information, in order to understand what is going on and then convert that and pair that with human history, decision-making experience into actual usable wisdom over time. And it's wisdom that then makes better informed real-world decision-making. I hope this helps. This is, I think, and for my money, a very valuable graphic and illustration that will help us to sort of understand the journey or the path we take, converting raw data into information, using cumulative information as knowledge, and using knowledge to hopefully aggregate, build wisdom for us then to make wise, real-world decisions for the sake of business, for the sake of our careers, for the sake of society, for the sake of all of these kinds of things. And therefore we get to then this very last slide. This, by the way, is also not in the textbook, so you should really take a good hard look at that, right? That the key, from my anecdotal experience in my career, the key for information systems is in delivering meaningful information, not mere data, but meaningful information to decision making. And for it to be meaningful and useful, that meaningful information has to be in a form that is timely, that is understandable, that is accurate, and that is concise. So let me try to explain that a little bit. Information is only meaningful if it's delivered in a timely fashion. In other words, in a time that is appropriate to still make meaningful decisions, right? You have to get the information in appropriate timing so that you have time to weigh it, analyze it, think about it, and consider what are the consequences of various types of decisions. Therefore, the information is only defined as meaningful if it's delivered in a timely fashion. In addition, then, as you see the second bullet point on the slide, of course, the information has to be designed and parsed in such a way that it is easily understandable to informed and trained decision makers. Now, to the complete outsider who has no understanding of how this particular company or business works, of course, the information may not be understandable. But to the informed decision maker, to the informed leader or manager, with the experience to understand certain types of information, that information has to be delivered in such a way that immediately, with very little effort, that decision maker is able to understand what the data is saying, what the information is saying, and what the appropriate analysis of that information would be. Of course, then, the third bullet point, that information has to be accurate. It has to be reasonably accurate to deliver the granularity, the granular distinction along scale that makes sense, right? And so, for instance, if you're looking at the big picture of the difference from month to month, how many bushels of navel oranges were produced, for instance, right? You may not need an absolute exact count of every single orange, but you need to have the sufficient level of granularity, perhaps by tens or hundreds of bushels, in order to really see the scale of the issue here, if that makes sense, right? In other words, the accuracy has to be reasonable to the decision being made. In that sense, then, of course, you see there the fourth bullet point I've given you, meaningful information is concise. In other words, it is delivered in the specificity and the conciseness, the brevity that makes a decision possible within the time frame that it needs to be made, right? If you say, hey, I need last year's sales numbers, and I give you back what I believe to be meaningful information, and the information is a report that's 22 inches thick, that is not meaningful information, right? Because it's not concise enough for me to be able to digest all of it within an appropriate time frame. This is important to remember, because remember, whenever you are compiling and translating data into information, that comes with cost, with time, with money, with resources. It takes all of those to convert data into information. And if you convert it, if you make the mistake of converting that data into a report that's 22 inches thick so that no human being can easily read it, right? Then you have not only delivered information that is not concise enough to be easily understood and analyzed, but you've also wasted resources, time, opportunity cost to develop that kind of report when that level of detail was probably inappropriate and rendered the information meaningless. I hope this makes sense, right? Is that you're constantly making decisions of how much is good enough, how much time and resources do we spend when we are making these translations or transformations of data into useful, meaningful information. The information then has to be timely, it has to be understandable, it needs to be accurate, and it needs to be concise enough to be useful to the decision at hand, to the decision maker, or the decision makers who will be charged with making that decision. I hope that makes sense. Thanks so much for your time. We'll see you in the next lecture.